Welcome everyone. Thank you for coming to my session on Bicep. I hope everyone enjoyed lunch. Now I've been told I'm not allowed to walk out of these little bits of sticky tape here, otherwise I go out of camera. It could be a favour to the remote audience, I don't know, but I'm going to do my best not to do that. So, can I get a show of hands who is already familiar with using ARM templates? Pretty much everybody, good. Keep your hand up if you have already used Bicep to some degree. Just a few. Okay, awesome. So ARM templates, as you're aware, they're a fundamental deployment mechanism for Azure. Very, very powerful. Myself as a consultant, come across ARM templates a lot in our customers when they are deploying to Azure. And again, they're very powerful, but they do come with a bit of a cognitive load. They can be very complex. The syntax is less than stellar. It works, very, very functional, but it's not as easy as what you'd like. It's not very modular, that's for sure, especially from a reusability perspective. At the end of this talk, my goal is that you will never want to use or need to use ARM templates ever again. My name's Paul Glavich. I'm a Telstra Purple consultant, a principal consultant. I've been with them for around 6.5 years now. My three main sort of pillars of focus are solution architecture, mostly in the cloud, DevSecOps, which is where this talk firmly sits, and augmented and virtual reality. As I mentioned before, as a consultancy in Telstra Purple, we come across a lot of different customers. They're using anything from Terraform, ARM templates, Pulumi, just standard API calls, but ARM templates are by far the most popular. So it's good to see that there is some, well, hopefully you're going to see at the end of this, there is some improvements to ARM templates. In fact, significantly more improvements. What we're going to do is cover this in three parts. The obligatory introduction, so we're going to get everybody in a level playing field around what actually is Bicep and why even bother with it. Part two is going to be sort of the meat of it, where we go through some usage implementation tips and tricks around it. And then we're going to bring it all together at the end with some short, but hopefully very cool and powerful demonstrations of things that it can do. What it isn't is a Bicep tutorial. I'm going to fly through a lot of stuff, so you're not expected, obviously, to remember it all. I'm going to try and keep it as cohesive as possible. And I'm going to cover, again, all the basics, right, to some more advanced stuff. But I am going to fly at speed because there's quite a bit of content there, and then we'll open up for questions at the end. So firstly, what is it? It is an abstraction over ARM templates. It's what's called a domain-specific language. And it works in addition. It doesn't replace ARM templates. It actually produces ARM templates. So you go from a Bicep file, you compile that to an ARM template, and that gets deployed to Azure. Conversely, you can actually go back from ARM templates to Bicep as well, and we'll see that a bit later on. It is significantly, and I say that categorically, significantly simpler than ARM templates, and the tooling around it, because they've been able to design it specifically this way, is exceptional, and in my opinion, way better than ARM templates. So, but the fundamental thing here is just another language, a simplified version, if you will, of ARM templates. But why come up with it? Why bother with it? Well, in Microsoft speaking to their customers, they do have some, especially with complex deployments, ARM templates can get pretty hard. So they want to make it easier for customers to deploy to Azure. And ultimately, they want to help customers become successful in Azure. So if ARM templates are proving a little bit complex and causing some issues, they want to try and mitigate that where people want it to be. They have interviewed many, I guess, customers, MVPs, people who are deploying to Azure around what might be the best approach. If you're familiar with Pulumi, that's a programmatic language and deploying to Azure. Bicep isn't programmatic, it's very declarative. It is this domain-specific language, kind of akin to Terraform, but it's not programmatic, and that's by design because they wanted to make it that way based on the feedback that they got. One of the most important things, though, there is what's called day zero resource provider support. So when something new comes out in Azure, Bicep, like ARM templates, support it from day one. There is no delay. I know with Terraform, for example, you might get a bit of delay in the provider support for new resources, particularly in preview. It's not the case with Bicep, just like it is with ARM, and I'm going to reiterate that consistently. But if they want to make something less problematic than ARM templates, but just as powerful, why don't they invest in something like Terraform and Pulumi? And the short answer is they still are. Both Terraform, Pulumi, they're really good options to deploy to Azure, and Microsoft does support them. Microsoft itself is investing in certain products for Terraform that allows you to reverse engineer resources back into Terraform templates. So they're more than happy for you to use any one of those. They don't actually care. As long as you stick stuff in Azure, you're good to go in Microsoft's eyes. But why not just improve ARM templates? And yes, they could sort of do it, but it'd be pretty disruptive, right? ARM templates, again, core mechanic, lots of customers using them, and Bicep is an attempt to improve ARM templates. And it's so seamless, as I hope that we'll show you today, that it is an improvement over ARM templates and a good alternative. But it's not at version 1, so why would you use it? A lot of companies, and Microsoft is no exception, don't have a great history at non-V1 products being super rock solid. I'd like to say that I think this is. Azure version 0.3, which is, I think it was May last year, they deemed it as production ready. It's currently at version 0.11. I've been using it since version 0.42 deployed to production with zero issue. The only thing, and again, I'm going to demonstrate this later on, is you can go from ARM to Bicep, Bicep to ARM, and even if something's not explicitly supported in Bicep, you can still use Bicep to produce ARM templates to deploy. It is 100% parity with what can be accomplished with ARM templates. It's supported by Microsoft plans, and I guess the main point here is, certainly in my opinion, in Microsoft's opinion, and eventually at the end of this, hopefully in your opinion, it's going to be safe to use for production, even though it's not at version 1. How do you get started with it? Download, install it, and it becomes just a tool on your command line. It's pretty easy to do. You can install it just as a singular tool, which is how you just do the standard download install. There's some PowerShell modules you can optionally use as well, and you can install it into the Azure CLI as well. So there's a few ways to go about doing it. All of them are identical in usage. The PowerShell version is a set of commandlets, so if you're more familiar with PowerShell or prefer that way, you can certainly do it. My personal preference and how I will be demonstrating things here today is using the Azure CLI or the integration with Azure CLI. And the reason I prefer that way and I'd recommend it is that A, Azure CLI is a pretty good tool. B, it allows really easy upgrades. It doesn't install it into your path and do all this kind of thing. If you've already installed Azure CLI, you just say Azure Bicep install or upgrade and it will just go along and do it. You don't have to elevate the prompt or anything like that. VS Code extension for Bicep, extremely powerful, and we'll have a look at that a bit later on, is again my preferred way of doing it. They recently, I think it was last month, released an extension for Visual Studio, which you can also use. It's not quite as functional as the VS Code extension, but it is there. In my opinion, the Visual Studio is a tad heavy if you're just doing Bicep templates, but you can do it. What does a Bicep template look like? And we'll get into some actual code in a second. You can see we've got the resource name. We've got the symbolic name, so you're saying resource of a symbolic name, in this case my symbolic name, not very exciting. The resource type, its API version, and then some properties there. And we'll get into a bit more detail, but one of the things to call out here is if you have a look at that, it looks sort of JSON-like, but you'll notice there's no commas at the end, and it's not using double quotes, it's single quotes. One of their design philosophies is they want to minimize as much as possible. And so when Bicep produces ARM templates, it sticks in all the double quotes and the commas. But in their opinion, them being the design team for Bicep, you don't need to put in commas. Bicep can infer it, so let's just save you a keystroke. We're ultimately lazy, which I am. In terms of first Bicep template, in fact, I'll just, we'll go from here. You can see here, this is actually for a storage account. You can see we're declaring a resource of my symbolic name. It's a Microsoft storage account at the API version. We've got name, location, kind, and the SKU type there. You can see also that we're embedding comments in there pretty easy as well. So again, nice little thing, especially with comments, with complex deployments, they can be very handy. So Bicep fully supports them. How does that translate to an ARM template? Let's go one step further here. So I'm going to go to part 1, the basic, call up my Visual Studio. So this is the template that you see here. And what I'm going to do is I'm going to say AZ Bicep build the file. I think it was main. Oh, no, sorry, I've got to go into the demo. Oh, come on. Thank you. AZ Bicep. And again, I'm using the Azure CLI integration here, so if I go version, it'll tell me the Bicep CLI version. If I need an upgrade, it'll tell me that to do an upgrade. But currently, I'm at the top. So I'm going to go AZ Bicep build, file, main, and hit enter. If I flick back to Visual Studio Code, you'll see here that a main.json has been produced. And this is the template that gets produced. And you can see here, standard template with a bit of metadata, just to say, hey, I'm from Bicep. And you can see the type, the API version has been split out, name, location, kind, and SKU, and the properties as well. And you can see it's using double quotes and stuck in some commas and all that. Looks like a standard template. Cool. That's how it starts to split things apart. But just to prove my point here, I've created a script. It's going to build out that Bicep file like I just did. It's going to do a bit of cleanup, which is not the important part. It's going to rename that main template that we just produced, and that's going to produce again. Oh, come back here, to main2, and then it's going to say Bicep decompile that template for me, which is going to create a main2.bicep, and then we'll have a look at the difference. So just to be clear, I'm going from this, compiling to ARM, and then I'm saying, hey, Bicep, decompile that ARM template back to Bicep file. So if I execute that script, if I can type, go back here, and eventually you'll see the main2 JSON get produced, and main2 Bicep, there we go. So have a look at main2 JSON. It's that template that we saw before. We have a look at main2 Bicep. It looks pretty much identical as the original one, except for comments. Main point here, gone from Bicep to ARM to Bicep seamlessly. It's pretty easy. And in fact, that's kind of what happens under the covers. But because of the integration, and you can see some warnings there, and I'll talk to those a bit later on. Because of the integration with Azure CLI, I can do deployment, group, create, file, main Bicep, and it'll just go off and do it for me. I don't have to compile it to ARM and then tell Azure CLI or PowerShell to deploy it, if that makes sense. Okay. So we just did a build or a compile of a Bicep template. One of the things that I like to do in my CI/CD pipelines is that prior to deployment is do exactly that, do a build of your Bicep file, and it will create a bunch of, well, it will error out if it's invalid. And I think like you saw before, when I was doing the build, Azure Bicep build main, it would have come up with some linting errors. And you can optionally use those as part of the output and even fail on those if you choose. But it will, again, will produce an error if you do a build and your Bicep file isn't valid, and you can stop it before you even gets to a deployment stage. Okay, on to part 2. I'll cover the basic data types and parameters, just again, so we're all on the same page here. Let's not go there, let's go to, so, enough of part 1, on to part 2. Variables in Bicep. It's not too hard to understand. Here we've got a parameter called environment. It's of type string. It has a default value of dev, and we've got some comments after it. Another parameter, type int, a default value of 1, 2, 3. This parameter is an array. You can see we've got the square brackets there, and the only requirement here is it needs to be on a separate line. You don't need to put a comma in. In fact, it'll have an error. It just needs to be on a separate line. Single quotes, remember. Similarly here, we've got, now those were parameters into the template. I'm constructing a variable that is an array, and we've got the square brackets there. I could actually do things like this, 1, 2, 3, create an object in there as well. That would all be valid. We're creating a variable, my bool, which is true, integer, we've got a string, and we're creating an object here. And fairly standard stuff. The syntax is pretty easy to understand. Again, similar to ARM and I guess some programming languages, but just a little bit different and need to be aware. A little bit different here, we've got a parameter which is an object, but we've decorated it with this secure decorator, and that creates a secure object, translation over to ARM. Similarly here, if you want a secure string, we're just calling it a string and decorating it with secure. Now, if I go and do what I did before, go back, I'm having trouble typing today. Okay, if I go and build that, where are we, vars, flip back to VS Code, oh, come on. Thank you. Yeah, where did you go? Oh, sorry, I didn't do the F. You see, I've just compiled, the Bicep file into traditional ARM. You can see it's compiled out the parameters. We've got environment type string with a default value of dev, and done what you would expect. With sensitive object, it's made it a secure object, sensitive string, secure string, and you've got the variables for my array and those other variables that we declared. Nothing too groundbreaking there, but the point being here, what you're seeing is that the start, or I guess the design philosophy of being quite succinct in declaring things, at least from a Bicep perspective. You will notice also in the VS Code editor here, I've got some squigglies under this because it's saying, well, none of these variables or parameters are ever used, so it's giving me some warnings as well. Onto operators. So I'll look at the operators here. So slowly, that's very basic stuff, obviously, with the data types. We're going to slowly introduce some complexity. So here I've got a parameter, and I've got a variable, which is of type object, and two properties in there as well. Here I'm declaring a integer of type 200. This variable, I'm saying take that variable and times it by 1024 three times. And that's obviously, again, quite easy to understand, but we'll have a look at the difference that is produced in an ARM template. But that's, like I said, quite easy. This coalescing operator here, we're saying if some object property is null, then give it a value of 1, 2, 3, else just retain the prop1 value. In this case, it is null, so it's going to be 1, 2, 3. This is prod variable is saying, well, if environment is equal to PRD, and we've passed in environment up here, then isProd is going to be true, else isProd is going to be false. We can then go a bit further and use a ternary operator and say, right, well, if isProd is true, then VM series is going to equal that, else VM series is going to equal that. And so in this case, we might be saying, well, if it's prod, we'll use a higher spec VM to the standard B series VM. And then we're doing some outputs here. We're saying, all right, the output for the SQL capacity figure is an integer, and it's equal to that value, which we calculated up here. Is production is of type bool, and it's equal to that variable value, and etc. for the rest of them. I'll do the same again. So I'm going to compile. I'll go to the right directory first. Easy bicep build f, whatever the file name was, operators. Just to see how that comes out. Because again, quite easy to understand now. And come on, you can do it. Oh, I did it again. Oh no, mistype. Fat fingers. All right, we've got operators JSON. So we've produced an ARM template. You can see we've got those parameters and variables that we described before. Capacity in gigabyte was 200, fairly easy. The SQL capacity value, where we times it by 1024 three times, you can see that that's, again, not super hard to understand, but certainly not as clear as in the Bicep version. And same for the rest of it. The coalescing operator, you can understand what it's doing. Does it look nice? Does it hurt my eyes? Yes. Still not that, it works, but not nice. Same with the isProd. If it equals PRD, then that's true, else it's false. And then the ternary operator that you saw in Bicep equates to this thing in ARM templates. And your output's there, fairly verbose as ARM is wont to be. Again, main point, we go flick back to this one. This looks and feels much neater. ARM template, messier. Okay, we're going to build on that again. And for that, I will go to the right directory again. And go to VS Code. So let's have a look at main in this instance. Whoops, sorry. Trackpads, I hate them. So this is a more, still a simple but more typical Bicep template. We're defining a location parameter of type string. We're saying, but it's of type, its default values of type the location of the resource group. If I hit Control Space there, you can see there's a few other properties I can do with the resource group. Similar to the resource group function in ARM templates, but a little more readable. We have an environment parameter of type string, but we're saying the only allowed values are dev, UAT, and prod, min length of 3, max length of 4 with those decorators. Now we're starting to use some custom functions here. So we're creating a unique part. We're using the unique string function. We're seeding it with the resource group ID. All that's going to do is just create a unique string that is unique within that resource group. It gives you a 13 or 14 character string. Again, you can do that in ARM templates, but it's, the syntax here is pretty easy. What's a little bit more interesting is we're doing some string interpolation here. So we're going, all right, the storage account name starts with my STG. We're doing the dollar sign, open squiggly bracket, environment, and same for the unique part. So if I start typing unique part in there, you can see I get that. And so we're doing some nice string interpolation there, which, again, in ARM templates, a bit messy, and we'll do the whole compilation bit. Now, creating this storage resource group, I'm using that variable at the location, which we passed in as a parameter. And in this case, it's of type blob storage. One of the cool things you can do here is you'll get some IntelliSense for blob storage, or for in this case, the kind. There's lots of IntelliSense for all the supported stuff within Bicep. For stuff that's not supported, you simply don't get IntelliSense, but it won't actually stop you from doing it, which is why if things aren't explicitly supported in Bicep, and it's rare, you can still do them in Bicep and have support from in ARM templates. And we're doing an output variable here of type string, setting it to the storage account name. Now, this is the one that I've constructed up here as a variable. I could use this symbolic name down here and say dot, and I can go to name if I like. Oh, there it is. Oh, I'll come back. Hang on. There you go. So I could use the name of it here, and you can see a whole bunch of other properties off the symbolic name. That's why we need the symbolic name for later references, if we want to reference tags and the properties and things like that. So that's just as valid. Now what we're doing here is deploying a new resource, in this case a storage account. What if I want to do an existing resource? In ARM template, you use things like resource ID to get the ID and stuff like that. If I want to do an oh God, trackpads, they're going to kill me. This is a new resource, but for an existing resource, we use the same resource keyword, symbolic name, its type. The only difference that we do is moving along, you use the existing keyword here, equals, and then we just provide the name of it. So I can reference an existing storage account. And that's in the same resource group. We'll talk about scopes a bit later on. We're defaulting to the same scope, which is one resource group. But if I want to reference an existing resource in another resource group, again, we use the existing keyword, and we give it the name of the storage account, and this time the scope of type resource group and the name of the resource group. Similar thing for in another subscription in another resource group. We just use the existing keyword at the end there, and use its name in the resource group, and we give it an output. Now, I'll do a compile or build of that. and that was a file existing, I think. Yep, cool, didn't complain. Should get a new file there, there it is. And so you can see for parameter, we've got the resource group.location, unique string function, where we did the string interpolation. We've got, this, what I consider ugly kind of stuff, but it works. And all the rest of it in there. So it's not too dissimilar, but it is simpler, I would say. And the reason it's actually left it out is because we're not left out the existing types is because we're not actually using it anywhere. So it's done some efficiency for us. Now the other one I wanted to call out just very quickly, this depends on example, and I'll just go through this template very briefly. We've got some parameters. We've got variables to determine a function name and app service name, again using string interpolation. We've got a storage account name. We have a storage account there. And down here, we're creating an app service, a function app, and that function app is referencing the app service ID, and it's also referencing storage account name and the environment suffixes. And we're actually getting the storage account keys, the very first key in its value. I'll talk to those functions a bit more later on. But suffice to say that this resource is referencing a bunch of other resources up there. So if we go and do the same thing, we'll go compile that or build that. Depends. And we should get the JSON for that. We'll get the expected JSON stuff, or the ARM template stuff. But if we scroll on down here, you'll notice that there's a whole bunch of depends on that Bicep has automatically put those dependencies in for us. We haven't had to do it. It's inferred that based on how we've used it and said, all right, you're referencing properties from another symbolic name. I'm going to put the depends on in there for you. If, and I could do this manually as well, I could go down here and say depends on and say app service. And it'll allow me to do that, but it will give me a little squiggly and say, well, you kind of don't need to because I'm really clever and I can do it for you. Okay, moving on. We did that one. You saw some of the functions in that Bicep template there. That was only a few. I certainly don't have time to go through or bore you, I guess, to go through every single function. It would be a pretty dry talk. But this is the list of functions that are currently available. In fact, there's probably a few more. Suffice to say that there is a hell of a lot there. Some of them directly translate into their ARM template counterparts. Some do not. Some do some ARM template magic, and we'll see some of those a bit later on, which kind of bend ARM to its will, so to speak. But there is quite a lot of functions there. This is where I think Bicep really shows its strength is in the use of modules. And what you've been seeing there, those Bicep files, is every Bicep file is a module. You can reuse those to your heart's content. And the way you use those is you reference them with a module keyword. You can see on the screen here, you've got the module keyword, again, the symbolic name, the name of the file, and then you've got the name, in this case, of the module or the deployment, as it were, and then some parameters that are passed in to that Bicep file. And let's have a look at that in more detail. Let's close down all of this stuff. Nope, nope, thank you. So let's have a look here at the main file. We've got some parameters, all good. Password, secure string, username, some allowed values for the environment. And we're referencing module, calling it the app service, and it's the app service Bicep. If we go into app service Bicep, have a look at that. It itself has a whole bunch of parameters. Similar to what you saw before, we've got an app service plan that's been created, the app service itself, and some output values. Going back up the top here, you can see all those parameters there. In the main, that's what we're specifying here. For the ones that have default values, it isn't necessary to specify it, although you can. So if I go here, it says, all right, well, you've got a parameter of SKU or Linux FX version, I can provide a value there. Scrolling down, I've got a storage account, and I'm referencing the storage Bicep file. And that's pretty simple. Looking again at main. A bit further on down, I'll talk to this in a second, and you've seen it before. I'm doing referencing a VM module. And that VM Bicep file is a little bit larger because that's what VMs do. I won't go into a lot of detail there. You can see a whole bunch of variables, network interfaces, NSGs, VNets, subnets, and eventually the VM itself. Main point here, though, is I'm referencing it as a module, passing in any specific parameters that I want. But I'm being a little bit clever here, and I've just introduced something a little bit more in addition to modules. I'm saying, all right, let's try and make this true or false. If the environment passed in is PROD, and if we go back up here, the only allowed values are dev UAT and PROD. This will be true if it is that value. And this is saying, like you saw with the existing keyword, if it's production, then deploy this VM. If it's not production, that won't get deployed. So we're starting to look into some conditional deployments. In addition, and again, this is where I think Bicep has its superpower, is the use of modules here. For those familiar with Terraform, they already have the concept of modules, a little bit different. But I'm separating out my concerns. App service here, storage here, and VM here. In addition, if you go look at the bottom here, some of the outputs, I'm referencing the module's symbolic name, looking at outputs. In fact, let's go outputs. Oop, come back. I can reference its name or its outputs. And you can see I've got app service name and app service plan name. So it's gone into that file. It knows what the outputs are. It's giving me IntelliSense based off that. That to me is quite powerful because, and let me at least try and give you the boom moment. We want, easy, Bicep. So let me show you what that looks like as an ARM template, because remember, it's all seamlessly interoperable with ARM templates. So I think it was main, yep. Let's go have a look. We should get a main.json when we do. So remember, we've gone from main Bicep, which is relatively small. We've got referencing three modules in there, to this main.json. If we have a look at that, you can probably see over the right here. Well, let's just scroll down for a bit of quick reading. And what it's done is it's embedded each of one of those files as a specific deployment object within the ARM template. So we've got a deployment, it's of type incremental, it's the app service deployment. You have a look here, and here's the full ARM template embedded. And we scroll on down a bit longer. We've got another deployment, this is the storage deployment, again incremental mode, and we've got that full ARM template in there. And we've just scripted over the VM one, the final one with another deployment, VM deployment, and again, the full ARM template. You know, it's not pretty reading. It's pretty ugly, actually. And while it's powerful as an ARM template concept, authoring these is quite painful. Bicep has allowed you to separate out your concerns here, reduce the complexity of your main template, separate out into separate Bicep files, but still maintain full compatibility with ARM, which again I believe is its superpower. You're reducing the complexity, therefore you're making it simpler to deploy, reducing errors, making your deployments more successful in Azure. Which brings us now to a solution structure. With ARM templates, it's not that easy. You can do sort of separate files with ARM templates. It's not a nice experience. You can use things like template specs to build it all together, but there's still some friction involved because you've still got to deploy that. You've got to maybe put it in a resource group even, or a publicly accessible URL for link templates, which is ARM hell in my opinion. But with Bicep, you can just come up with simple solution structures like this. So you've got your main Bicep file, which you'll see as a general pattern from the Bicep team. You don't have to call it main Bicep, but you'll see that used most often. You can just have main Bicep referencing the resource files in the same directory, or you can separate it out by directory. It's really up to you. Again, as you get more complex, separating it out by directory could be quite beneficial because you're separating out into the areas where it makes sense. And so if you're a team working on a big, massive deployment, this could be very helpful. We talked about the conditional deployment there. We're going to look a bit more at conditions. And again, it should hopefully, I should have kept that going. There we go. So let's close this down. So if the modules aspect wasn't enough, or at least it should have been a little bit, this should hopefully push you over the line a bit more. So what we're going to do here is I'm going to deploy a SQL server. Well, I'm not going to deploy it, but because it'll take too long. We've got a SQL server and a SQL database. What I've got up here in the database SKU is a variable, or an object actually, a variable that contains an object that has a dev object, a UAT object, and a prod object in it with all similar properties that are describing the database SKU. Going down a bit further, I've got database SKU properties, the collation, max size bytes, and zone redundancy settings. Again, for dev, UAT, and prod. So another 3 objects in another variable. Down here, for not the SQL server, but for the SQL database, I've got the resource type, the API version. I'm doing some interpolation for the name, location. But for the SKU and properties, I'm referencing the database SKU variable by its indexer, and I'm passing in the environment parameter. And that environment parameter, back up the top, only has the same allowed values which are in our variables here. So I'm kind of extracting out the database SKU and SKU properties into an area that is in the same location, at least all in the same area. It's easy to see the difference between dev, UAT, and prod. I don't need separate templates or anything like that. And then I'm just referencing it down here. I could optionally, if I wanted to explicitly do it, just do dev, UAT, and prod, but because I'm passing it as a parameter, I get to take advantage of it that way. That's not bad. We're making it a little bit simple. I could do it a different way as well. For example, down here, I could say, well, the database SKU, if it's production, has these properties, else it has these properties. It's still a bit messy in my opinion. We can do better than that. If I go to this file here, what we're going to do, so the same thing again, same parameters up here for environment and so forth. What I'm doing for the SKUs and SKU properties though is I'm using a function called load JSON content. And I'm specifying this SKU settings directory, and in this case, dbSKU.json. If we just have a quick look at that, this is your standard JSON file. It requires all the regular things that a JSON file does. You've got apostrophes, commas in there, all that kind of stuff. But you can see we've listed out all the dev, UAT, and prod SKU properties, or SKU settings and SKU properties in this other file here as well. So we've got another file. Just a JSON file with dev, UAT, and prod objects in it with the subsequent properties that you saw before. Now going back here though, not that one, that one. We're just loading those in from a file, so it's not part of this template, making the template very, very small, and we're referencing it in exactly the same way. Okay, if I do a dot here, you'll see dev, UAT, and prod. Now, if I go to just so you know that I'm not lying to you, if I go here and I'll copy, say this guy, put a comma there so it's valid, and we'll say NDC, save that away, I'll go back to conditions 2, and I hit a dot, it's NDC. So you can see it's going off to, and this is more the extension than Bicep, but I'll show you how this magic happens in an ARM template. Bicep and the extension in this case is going into the file, the JSON file for you and providing you some nice IntelliSense. But more importantly, you're able to, again, strip out more complexity of your template into a separate file. In this case, I'm just grouped all the SKUs together. So if I ever wanted to change it, I can just go into that without having to touch the main template at all. I think that stuff is really powerful. But let's have a look at, because that's not really native when it comes to ARM templates. Let's go have a look at how it actually does that. So we're in demo 7. Easy, bicep, build, F, conditions, number 2. Let's go back into VS Code and have a look at the magic happen. So we've compiled that down. Let's have a look at conditions to ARM template. Got some parameters, not exciting. But we do notice some variables here. We've got this weirdly named variable that contains dev, UAT, and prod. And a bit later down, and NDC of course. And we've got another weirdly named variable, dev, UAT, prod. Again, those same JSON files that you saw before, it's embedding them in the ARM template as variables. And then it can go and reference them later as the SKU and properties. And you can see it's doing stuff there. In fact, I missed a bit here. Sorry, one sec. Where were you? There was the variable. Got that one. Ah, yeah, sorry, there it is. So DB SKUs referencing that variable there. DB SKU properties referencing that variable, and then it references it down here. So what Bicep is doing in this case is taking ARM in a bit of a headlock, twisting it around and making it do its evil bidding, but ultimately making it nice and easy for you from a Bicep perspective, because you've separated out into JSON files, separated out into separate resource modules and utilize modules to get it all done, but still 100% compatible with ARM, making it simple, making it less complex, much easier to maintain. And again, I think that, in addition to the modules, is by far and away a massive improvement over ARM. Okay, we talked about that bit, but yeah, just to ram it home, surprised cat GIF, well, not quite a GIF image, but load JSON. That's one of the an example of one of the functions where that's not native to ARM, but it does create some. Bicep does the magic behind the scenes to make ARM work the way that you think it should. We did that one. All right, just quickly, I think how are we doing for time? Yep, so a little while. Just quickly on loops, I won't go into too much detail here because the next part is, I think, a little more valuable. In terms of loops, if you cast your mind back to conditional deployments or existing resources, loops are done kind of similar. So let's have a look at how they're done. So again, we'll create, up here we've got a variable. We've got a string in this star array. Open square bracket, then we've got for I in range 0 to 3, a little colon, and then some string interpolation here, and closing the square bracket. So the open square bracket, close square bracket is where you're going to declare a loop, and we're using a range function in there. Fairly easy to understand programmatic syntax, and obviously that will go from 0 to 3, and you'll get, at the end of the day, this output here. So stuff 0, stuff 1, stuff 3, because that's where it's doing some string interpolation and a bit of computation there as well. Using that to create, say, multiple resources, for example. Resource, symbolic name, the type, in this case we're going to create a few IP addresses, equals, now normally we'd see the existing keyword or the conditional deployment. We're sticking in the loop construct for index in range 1 to 3, open bracket, and then you've got your regular Bicep syntax in there, damn it, and the close of the square bracket there. And so all that will get done effectively 3 times. Okay, that's the simple version of the syntax. There's a little bit more you can do. So if you wanted to reference not just the index, for example, but the item within an array, we've got a web app list. It's got 2 objects in there. I'm going to create a few apps, or 2 app services in this case. So again, the resource, symbolic name, type, open square bracket for item, comma, index in web app list. So it's going to give us each item as well as the index. So for the name in this case, we reference item app name, which is this one. And then For the app component in tags, we're referencing the item app tag. So we're just iterating over an array. It's got 2 elements in it. We're picking out the properties of that array so we can do this resource creation multiple times and utilize the properties in that array. We're also utilizing the index here just to do a bit of funky stuff and create a component number, which is just some made up construct on my part. Just to show you that you can reference the index, get the length of the array, and compute on the index as part of that looping construct. So again, pretty simple, getting a little bit more complex, but again, certainly if you're used to ARM loops, this is a much easier construct to understand. All right, on to part 3. This is the bit that I like, because am I too lazy to type? I'm too lazy to do almost anything. But let's say, go over to here, too lazy to code. Go to main Bicep. All right, so you've seen that the templates are quite simple, or are much simpler than their ARM counterparts, but you still don't really want to be doing a template from scratch. Specifically, let's say a VM that's quite hairy. Let's go res-vm. We'll go, oh, I want an Ubuntu. Booyah. There's all the properties that you need to fill out for VM. Or if you want res-AKS cluster at the very top there. There's even more stuff for you. So that stuff's pretty handy. You don't have to kind of go to the reference. You just get res-boom and pick your resource type, and you've got all the properties there ready to fill out and go. That stuff's pretty awesome. What you can also do is I've already got an Azure subscription, and in that Azure subscription, I've created a storage account. And as you know, with all resources in Azure, they have a resource ID. What I'm copying and pasting here is that resource ID, which is easy enough to get to the portal. In the interest of time, I won't go to the portal now because copying and pasting a resource ID is largely boring. But what I can do with that, so I've already got an existing resource. I'll go Control-Shift-P and I'll call up the command palette and say, all right, here Bicep, I want you to insert a resource into this file here, which is my too lazy to code and incorrectly spelt main.bicep. So I'll select that one. I'll paste in the resource ID, hit enter, and with any luck, hey, so that's gone into Azure, found the resource, generated the Bicep template for me, stuck it into my file for me. So it's like a really easy way. If you want to play around in the portal first and get your resources right, then find the resource ID, whack it into your Bicep file, delete the damn thing, redeploy it. It's all easy. You don't have to go and generate an ARM template in the portal, go to Resource Explorer or any other number of ways. You can literally play around in the portal and then create your template really, really easily for it. So I'm hoping all this is pushing you over the edge towards Bicep. Yes, note about scopes. I did mention I would talk about that. The default scope in a Bicep template is resource group, as you'd expect. It does support all the other constructs, such as subscription, a management group, and tenant. And so we'll go and have a quick look at that. For those who may or may not be aware, you've kind of got your management group at the top level, and then you have a subscription or multiple subscriptions underneath, then down to resource groups. So if I just jump quickly into VS Code, it's probably an easier way of doing it. In this case, and with target scopes, it has to be the first line of your Bicep file. And in this case, we're targeting subscriptions, so not the default. If I go here and say, all right, you'll see it'll give you IntelliSense for what you can provide. We'll put subscription back in. And I'm saying, all right, I've got a resource here of some resource group. I'm calling it group 1, and the location is deployment location. Pretty easy. I've got another resource group here in a different, the same location, but it's called something different. And using those two resource groups, I can deploy, in this case I'm using modules, so a storage account, to each of those resource groups. So I'm not deploying, and the point is I'm not deploying just to one resource group. I'm saying, all right, target the subscription, create 2 resource groups, and deploy one resource, in this case a storage account, to each of those resource groups. So the scope has increased to a subscription level, not a resource group level. And you can do the same with management groups as well. It's as simple as that target scope element up there. And obviously you need to do the scope as part of this module. I'm determining the scope here, saying it's a particular resource group in addition to that target scope up here. All right, did that one. Okay, let's not look at that, let's just go see it. So, in addition, with all those cool advantages, you do have the option of visualization in Bicep. So we've got, and I won't go into detail too much, but we've got a Bicep template here. Got some parameters, we've got a SQL server, database, website. What you can do, I could right-click over here and go to visualization. I'm just going to go to this little icon here, click that, and if you can see that okay, let's drag it over. You can see it has visualized it nicely for us. But what about if we want some more? Come on, work with me here. So if I go down here and go res VM, and I'll choose an Ubuntu, you can see it put it in over here. Let me zoom in a bit. There's our Ubuntu VM, we've got roles assigned. If I'm scrolling around here and I go back to visualization, double click on that, it takes me to the Ubuntu VM I just created. Let's create something else because it's just easy. AKS cluster, oh, it whacks it in there. So we've got some dynamic visualization on top of that as well. Again, it's giving you all these cool ways to simplify and visualize the construction of ARM templates or just deployments in general, particularly the modules concept, but all this, particularly these VS Code extensions, which again are slightly ahead or reasonably ahead of the Visual Studio extension, give you a really powerful tool set for Azure deployments. Just as a bit of an aside, there is this thing called the Bicep Playground. It's good for learning for the most part. You can go here, and it's just a general website, grab a sample template. Let's go to Key Vault main, I guess. And what it does is it gives you the Bicep and the corresponding ARM template, and you can go and edit stuff in here. I think you can do like var blah equals 1. Oh, not car, but var. There you go, and it goes and generates stuff over here for you. So if you wanted to go and play around with it and see what the counterpart is in ARM and Bicep to ARM, you can do it through this website as well. And it's got a whole list of sample templates. And you'll notice they're all main.bicep as well, hence that sort of style guideline that I mentioned before. What's happening for Bicep in the future? If you go to that URL, you'll be able to see what is ahead for Bicep. I took that screenshot, where is it, version 0.7, which is only a few months ago. They're up to version 0.11 at the moment. They're looking at going version 1 around the end of this year, maybe early in the new year. But they usually do a version every month. But to see what's coming and even to suggest new things is you can go and raise issues on this GitHub board. And they're pretty prompt. They're a good bunch. They're really friendly, quite responsive. So if you've got something to suggest or just want to see what's coming, go have a look there. Actually, before I go into this part, I think one of the things that's coming next is with ARM, you've obviously got parameter files, which are standard JSON files. It's the same for Bicep as well for using parameters. However, they're looking at a Bicep parameter file that will give you the IntelliSense and lots of compliance enhancements in the parameter file as well. So you'll be able to do something like using main.bicep, and it starts to give you IntelliSense because it knows what parameters are going to be needed for that file and give you a whole bunch of enhancements on top of that. They haven't built that yet, they are building it, but that's one of the things that you'll see coming in the future. So in summary, I know I've only got a few minutes left. Bicep is simpler than ARM templates. And again, I would like to categorically state it because I think it's pretty evident. It is 100% ARM compatible. It's a win-win situation. You can stick with ARM templates if you want. You can do Bicep and ARM templates, or only Bicep, leave your ARM templates in place. You can reverse engineer them to Bicep if you're so inclined. You can do all of that. There's no loss. It's not a lossy conversion. The tooling, as you've seen, is pretty fantastic in my opinion, and it's only going to get better. The composability and reusability is a big one for me. The maintainability of ARM templates is again, in my opinion, less than stellar. Bicep makes it significantly easier. And I honestly, ever since using version 0.4, I haven't gone back to ARM templates. Where I get a chance at customers is I convert them to Bicep templates. Don't always have the time and the luxury, and you can stick with those ARM templates forever and a day, and you can use them interchangeably as well. There's certainly nothing stopping you, hence that 100% ARM compatibility. So, the challenge to you is if you're doing ARM templates today, decompile them into Bicep, give it a shot, parameterize a bit, and again, never look back. If you've never used ARM templates before, and I think most of you have, just start with Bicep and still never look back. It's a bit of a theme. So hopefully that's been educational for you. Hopefully I've convinced you to use Bicep. Honestly, I've never looked back, and I think you'll do the same once you start using them. There is no downsides to using it, there is only upsides. So thank you again for turning up. I appreciate your attention and your time. Is there any questions? Yes? Yep, so the question was, is there a way of reverse engineering an entire resource group into your Bicep template? Yeah, look, I believe you can just specify the resource group resource ID, and that should do it using that IDE. I haven't actually tested that, to be honest. Yes, yeah, I think if you do just specify the resource group, it'll do everything that's contained in it, I think. Probably worth testing that one, though. Because I only actually found out about the that little feature not so long ago, so I haven't fully put it to the test. Any other questions? Yes? Reference remote modules in a Git repo. Yes, you can. There is the, I'm not sure if you're familiar with things like template specs, which is a way of referencing ARM templates remotely in your Azure portal. There is a concept also called a Bicep registry as well, and you can put your Bicep files into Azure, apply RBAC rules to them, and reference them that way as well. So it's a longer answer to your question. Shorter answer is yes. Longer answer is probably better off using registries, Bicep registries for that, because you've got better security controls. Yep. Any other questions? Yes, of course. If you put, put kind and you're supposed to put blob storage, or only 4 allowed values, and you put something like Rumpelstiltskin, yes, yeah.
Why don't they provide libraries so we don't have to type and select?
Not sure. I'd have to speak to the team on that one as to why they don't do it. Yeah, I don't know. I don't know the answer to that one. Raise it on the GitHub issues there. My pleasure. Any other questions before we wrap up? Awesome. Thank you very much for your time. Go out and enjoy the rest of NDC. Thank you.